Trick question. Number one's a trick question. It says, if AB equals BC, then B must be the midpoint of AC. What I wanted you to think about is I wanted you to kind of picture this drawing here, where if we have A, B, C, let's put that close to the middle. And I say these two things are congruent. It says then point B is the midpoint of AC. Is B the midpoint of AC right now? Yes. So the trick question of this is you'd probably put, yes, it is. That's not the correct answer. It doesn't have to be the midpoint. And this wouldn't be something I put on a quiz or a test. But it only says that AB equals BC, right? It never said it made one long segment. So you could have done something like this. B is no longer a midpoint because a midpoint has to be a segment. It never said that it had to be the segment. It never says that B is on the segment. So it's a slightly trick question. Once again, that will not be on a quiz. That will not be on a test. It just gets you to give me the wrong answer and go, gotcha. I'd rather have gotcha questions on the bell work than on a quiz or a test. All right, on AB, how many points are there? Whose distance from A is 3 centimeters? Who thinks they have that answer? Yeah. There's exactly one place that's exactly 3 centimeters from A. That was the one I said will most likely show up on a test. And that looks something like this. If I have AB, and I need 3 centimeters from A, it doesn't matter how far 3 centimeters is. So we could say this is 3 centimeters. This is the only place that's 3 centimeters from A because I can't go the opposite direction. So this is the only place that could be 3 centimeters from it. If I took a ruler and just marked it, that's the only place. If it's a line, how many places can be 3 centimeters from A? 2. There can be 2 places. Might this be the first class that gets that right on the test? Who knows? It's never happened where everyone gets it right. We'll see. So if I have line AB, once again, if I just made marks 3 centimeters, say that's 3 centimeters, I can also make it on the other side. So that means it's 2 places I can make that mark. Cool beans? The beans are all cool? All right. I don't know why you'd want cool beans. I guess I'm picturing baked beans. Maybe like green beans, you probably want cold. Man, those are good. Anyway, that doesn't make any sense. All right, let us go through some homework questions. And I know the 2 we want to go through first. I'm going to go through 15 and 16 first because we need to be clear on those. Sure. Is there a marker back there? Yeah. Yep. What was that?
And then I just look it up from here?
Well, you kind of work it out from there. So remember, we're trying to find PR, right? Mm-hmm. We're trying to find PR. PR is our entire length, correct? PR is the entire length, including PQ and QR.
So that would be 19, and negative 6 plus 25 would be 19.
Yep.
I don't, okay.
And you get, and that's the correct answer.
Oh, okay. Wait.
Does that make sense? Okay, for those that didn't follow the work back there, let's go through it up here. So our job is to say, okay, these two things are equal because they gave us the length PQ and they gave us the length PR. And those two things must be equal because if I give you that length and I give you that length, they have to be equal because we have our tick marks. So we do that and we work through this and we end up with x equaling -1.
So we read something wrong. Wait.
Did you get x equals -1?
Yeah.
Well, so what some people will do is they'll just plug the negative in for one of them, and then they'll be done. They'll say it's 19, but it's not 19. So if I plug in -1 for this 6x plus 25, it'd be 6 times -1, which is -6, plus 25, which will give me 19. 19 is not my answer. 19 is just half my answer.
Wait, so we don't even have to work out the other one because
We-
we already know 19.
As long as we did it correct. The only reason why I might plug it in is to check to make sure our work is correct. Because if this is 19, this has to be 19 if I did everything correct.
Oh, so I just did extra work then.
You did a lot. I would still do it in my head at the very least, just to make sure it comes out to 19, to make sure I did all my work. Because if I plug in -1 in here, we have 16 minus 3 times -1, which would be 16 plus 3, which would be 19 again. It is a very quick way, because if I see they both come out to 19, I did it correct. And now I just have to say, oh, then the entire length PR equals that 38. Does anyone, any of those steps re-explain for number 15, or does that make sense?
So you plug in -1 for both x's and then calculate.
Yep, and that's it. We just have to be careful of what they're asking, because if this said find PQ, I just would have plugged -1 in for PQ, and my answer would have been 19. We just got to be clear of what's being asked of us and what we need to give for our answer and what's given to us. Because I'm guessing what's given to you is what confused a lot of us on this problem. Are we okay moving on to 16? Are we sure? Don't sit there and go, I'm not sure, I'll figure this out on my own, because that's not what this class is for. This time, yeah.
Where did the 19 come from?
Where did the 19 come from? The 19 came from, so I kind of did a little hand waving action. I basically said, see this PQ is 6x plus 25. So let's write that below. Let's go. Okay, PQ equals 6x plus 25. So all I did is I just kind of did some hand waving, probably while you're writing. And I said, I'm going to throw that -1 in for that x. And I said, you know what? If I have 6 times -1, that would be -6. Plus 25 would give you the 19. So if you take the time and plug the -1 in there, that's when you get that 19. And also, if you take that -1 and plug it in for that x right there, you're also going to get 19 out. Because both of those have to be equal, so they both would have had to come out to 19. Is that better?
Yeah.
Okay, good. Okay, let's move on to 16, and let's get our groans ready. Because this was all possible from every one of you. You could have done number 19, you just misread it a little bit. And you're basically led to misread it. Does this say PQ equals 9x minus 31? All the other ones said PQ. So we kind of thought it was the halfway point. So we just kind of lulled ourselves into thinking that all of these were the same. Well, let's draw the line real quick. PR, whoop, that's not a P, that's a P. PR is actually the entire length where Q is our halfway point. Every other one of these gave us these two tick marks, and we had to do something with it. This one actually tells you the entire length PR equals 9x minus 31. That's the entire length.
Also, all of those 43 plus 43 is equal to 9 minus 31.
Yes. So we go to QR, and we go QR equals 43. But we should not have written 9x minus 31 equals 43, because that doesn't make sense. The whole length doesn't equal half the length.
I was just thought it was, I don't know. I didn't know this was, I don't know.
Does the drawing help, though, make sense of it?
Yeah.
Yeah. So we have the entire thing is 9x minus 31, but the whole thing doesn't equal 43. Half of it does. So if this equals 43, what does PQ equal? 43. So what's the entire length equal? Well, it'd be 43 plus 43, so that would be 86, like you mentioned before. So the equation we should have solved was not 9x minus 31 equals 43. It should have been 9x minus 31 equals 86. And that's why you probably did it. You did everything correct or thought you did everything correct, and all of a sudden the answer key said something different. It's 13.
I thought something.
Yeah, I don't like that.
You just...
I got 14.
Ooh, sounds like a familiar answer. All right. So don't feel so lonely. A lot of people got 8.2. Does that make sense? Do you want me to go further, or are we good with that? Okay. What other questions do we have while I have these up? 5? Five is the exact same questions these are, except they're making us find the points first. So we need to understand that, well, if I don't put any numbers on there, we're going to count by ones. So if I want this point, we always do left, right first, up, right second. So this will be point 1, 2. So that's going to be the point 2, comma, and then how high is it? It's 1, 2, 3, 4, 5, 6, 7. So that will be the point 2, 7. Our other point, we have to go left, so that'll be negative 1, 2, 3, 4, 5, 6. So that'd be negative 6. And we have to go down 2, so that'll be negative 2. Now our distance formula says we're going to take the square root of those subtracted, added together, and squared, kind of. So it should look something like this. We'll take our 2x values and subtract them. So that'd be 2 minus a negative 6 squared, plus, let's subtract our y values. We have 7 minus a negative 2 squared. After that, or you just got, I think it was just coming up with the points that probably was the, you good then? All right, awesome. Other questions? Yeah. Yes. We're going to start the lesson, so you're going to have to get the notes from someone. But yeah. Okay? All right, I will say we're packing a punch in this lesson again. This is kind of a typical like Thursday. It's not going to be always. What that means to you is this homework will not be due on Monday. It will be due on Tuesday. This homework will be due on Tuesday. But I will tell you on Monday I'll hand out the review. So if we don't get to the review on Monday, that's okay. We'll do it all. We have all day Tuesday to work on the review and answer questions. But I do want that honest effort over the weekend that we at the very least look all over the stuff and go, you know what? I'm not sure how to do this one. I'll ask this on Monday. I don't have the time to do the whole thing, but I can look at this one and go, yeah, I don't even know how to set this one up. All right, let us push through. We got a lot of information. We're going to talk about angles. The unfortunate thing is I'm just going to throw a whole bunch of terms at you, and we just need to know them. All right, the first thing is an angle is formed by two, well, this isn't even something that you need to really look up. So to make an angle, we have these shapes right here. Are these lines? Those are rays. So you could have probably answered this question, an angle formed by two rays. So we don't have the example right now. Well, let's actually do this. So if I ask for what are the sides, you better tell me they're rays. In this case, they're going to be the rays BC and the ray BA. Now you should look at the board and say, Mr. Pabian, you didn't tell me those are rays. Remember, if I don't put anything above it, it's a distance. How do I tell the person for a fact these are rays that they're looking at? Yeah, just you draw a ray above it, right? That's why we name them in the correct order. Was someone knocking? Okay. Oh, hey, welcome back. So I'm going to have BC and BA. Remember, it's important that we put it in the right order. That B is the segment portion, and C is our line portion. Remember, the segment and line get put together, it's array, so just make sure you order them correctly. This endpoint, B, where they're meeting up, is called the vertex. That is called your vertex. So if I asked for the vertex, you would just say it's B or point B. I'll accept either one of those answers. Your vertex is B. Maybe I'll point to that. I'll say, you know what, this is my vertex. If I ask for sides, we're going to give those rays. Oh, I kind of blew it. The rays are called sides. The rays are called the sides of your angle. So this would be a side. This would be a side. So you have two sides and a vertex. And you have an angle, reminding yourself that a side is a ray. A side is a ray. Hey, guess what, guys? Your sides are rays. Why do you think I keep saying that? Because I want you to remember it, and what do you think happens every single year? You forget and you write it's a line. It's a ray. Yeah.
A side is a ray.
A side is a ray.
Oh, yeah. Okay.
A side is a ray.
A side is a ray.
Okay, naming an angle you're going to use most of the time. Remember lines, you could put like a lowercase letter by it? Remember like if you had a quiz and it said name another name for line R and you'd have to use 2 points? Remember that? So there's two ways to name a line. We can use the 2 points or we can use the name that's given to it. Kind of the same in angles. So typically we're going to use 3 letters, the 3 points that comprise it. The middle letter must always represent the vertex. So you don't get to pick what order you want to name them in. You kind of do, but one needs to be fixed, and that is the letter B. So if I was going to name this angle, I'm going to do it underneath. I would go, okay, I can call this angle A, B, C, reminding myself that the key part is that B is in the middle. Or I could name it angle CBA. Once again, the vertex has to be in the middle. Yeah?
So if you're asked how to, what's another way to say it,
Mm-hmm.
name it, if we just write the word angle and then that, would that be wrong?
Not technically, but let's save some time and actually do this. It'd be kind of like doing line AB would technically be correct, but we like the symbol above it. So would I take off points? If I'm in a bad mood, maybe I'd take off a half point. Because we should know the symbols, right? Okay, so we have angle ABC and we have angle CBA, realizing our vertex is in the middle. That's the primary way we name angles. We're going to talk about a couple different ways. The first other way to name it only works in one case. So if you right here it says use a single letter if there's only one angle located at the vertex. So now this isn't a trick question. How many angles do you see up here? 1. There's one angle, so you can use one letter to name it. So you could, in this one case, call this angle, let's go back to black. You could call this angle B. It's not my preferred, but you could call it angle B because there's only one angle that could be angle B. Now, I like to refer to times where you cannot use a single letter. And let's go right. Maybe that's not a great one. Let's go here. There is a whole bunch of angles pasted together. We have an angle here. 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 All of those angles has the vertex B. So if I said look at angle B, you wouldn't know which one I'm talking about because there's a whole bunch of angles. So this is the case where you cannot use one letter. I would get in the habit of using 3 letters as long as it's possible, as long as I give you 3 letters. But know that maybe in the question it might ask you. So I might say, name 2 other ways to name angle B. That way you know which one's angle B, that we use those 3 letters. All right, when referring to the measure of an angle, us, probably use. I should probably say use a lowercase m. For example, if I want to tell you that this angle is 60 degrees, I would say the measure of angle ABC is 60 degrees. We will not write ABC equals 60. We will not put angle equals 60. We will put measure of angle ABC equals 60. So if I want the degrees, we use the term measure. All right, some of that might be new to us. Maybe some of us have already seen this stuff. A lot of us have seen the next part. If I have an angle that's less than 90 degrees, do you remember the name of it? Acute. It's a nice little acute angle. What if it's bigger than 90? Obtuse. What if it's exactly 90? All right. Reminding ourselves that that little box that's drawn on there tells you it's 90 degrees. So rather than me writing 90, I'll put a little box there. What if it's a straight line? What's the name of it if it's a straight line?
Wait, let's start with an S.
It starts with an S.
Sub.
What if it makes a straight... Oh, there you go. It's straight. It's called a straight angle. If it forms a straight line, it creates a straight angle. What's the measure of a straight angle? If I ask you for this degree measure that goes all the way around, 180, you need to know that. It is the only angle I don't have to label, but you know for a fact is 180 degrees. So if you see a picture, you automatically know that's 180 degrees. All right, quick example. I have this angle right here. Can someone name the vertex of that angle? Got one person, two people, three people, four people, five people. Let's go over here. Anyone, shout it out. You're saying K? I agree. The vertex is just K. You could put point K. If you absolutely agree with KL, I should probably put the ray above it, right? What do you get for the other one? JK, I would not put it in that order. I would put it in KJ, just so I can put my ray the same direction. So sides are probably the hardest one. Sides are the ones that you're going to miss on a test. If I ask you to name the sides, we're going to go out of left field and we're going to pick crazy stuff. They're just rays. All right, give 3 ways to name this angle. I'm going to give the hardest one, and that is there one angle up there? So you stole it. That's what I wanted. We can call it angle K because there's one. That is not typical, but in this case, there's only one of them, so we can call it K. What else could I name this? What did you get, Lex? LKJ. Cool. Did you have the other one? JKL. Remember, we just have one rule. That vertex needs to be in the middle, or we have to use the vertex. You know what a good rule of thumb is? If I name an angle, you better be able to draw it in the order I say to draw it. So if you tell me to draw the LKJ, this is what I'm picturing in my head. LKJ. Did I make that angle? If I went the opposite way, JKL, I would draw that same angle. Now, here's what's going to happen. It's going to happen in this class. Someone's going to name it out of order. And then I'm going to draw it. So if you tell me JLK is the angle, what I'm going to do is I'm going to draw JLK and ask you, is that the same angle? No. You're telling the person how to draw the angle. So if you're ever confused, how would you draw it? And you'd put it in that order. Obtuse, right, straight. Obtuse. I kind of gave it away by doing the first one. All right, let's keep pushing. Congruent. What does it mean to you if I say congruent? When I say the word congruent, what should that mean to you? Same?
Yeah.
Equal?
Yeah.
Somewhere along those. Remember we had congruent segments? We put tick marks on it because it means it's the same length. Well, if I give you congruent angles, that must mean the same sized angle. It's going to be the same sized angle. Do you agree that A and B are 75 degrees? Both of them? So those are congruent. Now, before I fill this in, like I said, for segments, we put tick marks if they're congruent. For angles, we don't put tick marks because it wouldn't make sense, because if I did this, it would look like, are you telling me these segments are congruent? That doesn't make any sense. So for angles, we actually use arcs. I put little arcs on there to say those are incongruent. What would happen if I had another pair of angles? Do you think I would use one arc? I would use 2 arcs. We could use 3 arcs. We could use 4 arcs. And if it's within the same picture, we just keep adding how many arcs they match up. All right, so now, are we clear that congruent angles are just the same size, right? So the mathematical way of putting that is basically if the measure of angle, what do we have, A, is equal to the measure of B. If I use the letter measure, I have to use the equal sign because measure is in place of a number. This is me basically saying 75 degrees equals 75 degrees. Measure equals degrees. Then we can say the angles are congruent. This just says the angles are the same. I'm sorry, the degree measures are the same. To say they're congruent, we have to use the congruent symbol, which was angle A. It's that equal sign with the tilde above it is congruent to angle B. So if the measures are equal, then they're congruent. That's what this says. If the measures are equal, then the angles are congruent. One more time. Measure says the degrees. This just says the shapes are the same. Shapes are the same. This is saying the numbers are the same. That's why with measures we use equal signs. Without measures we use that congruent symbol. 12:01. We got about 4 more minutes. We can do one more thing. Bisector. What did you think when I say bisector? Cut in half. Cut in half. So if bisector means cut in half, that must mean an angle bisector is an angle that is cut in half. So once again, bisector, I'm thinking cut in half. So an angle bisector is going to be a ray. It can also be a line. It's just typically a ray that divides an angle into 2 congruent angles. So if BD was a bisector, that means it creates 2 congruent angles. Remember when we had a midpoint? If we look back there, what did I do to show it was a midpoint?
The lines.
I put the tick marks on it, right? The same thing's going to happen for an angle bisector. It works just like a midpoint. That I need to tell the reader that those 2 things are congruent. So what we're going to do is we're going to put little arcs on it. If that was computer generated, it would actually look like one big arc. But when I draw it, I like to put them away from each other so you know that those are 2 congruent angles. So can we see the 2 new angles that are formed by it? So we started with a big angle, and then we cut it in half. That's all we're going to put down here. In the diagram on the right, if BD is an angle bisector, BD is a ray. If that's a bisector, then it would create 2 equal angles. And the 2 equal angles would be angle ABD will be congruent to angle DBC. Notice I didn't put measures, so we use the congruent symbol. But I'm just saying that we took that big angle and we cut it in half into 2 congruent angles. Good? Okay, let's put a pin in it and we'll finish this when we come back. So what we're going to go on to next is we're going to go on to perpendicular R. Apparently when I printed these, I must have, at the last second, nudged this over and that R should actually be there. So that should say perpendicular lines. When you see the word perpendicular, just like, I want you to not look at the whole thing all the time, because we can have other things that are perpendicular. Like when I say bisector, I want you to think cut in half. When I think of congruent, I think of equal items. That way, whatever I put after it, you can kind of suss out what it actually means. So when you see the word perpendicular, you need to start thinking of 90 degrees. 90 degrees is what we need to think when we say perpendicular. So what perpendicular lines are going to be, they're going to be two lines that intersect at a right angle, or they create 90 degrees. There'll be two lines that intersect at a right angle. I don't know why I gave us that much space. So if we look here, we have line L and line M, and we have that 90 degree angle right there. Now, let's be clear, when we have perpendicular lines, do you see this 190 degree angle right here? What's the measure of this line that I'm drawing? What's the measure of that straight angle? 180. So if that's all 180 and that's 90 of it, how much is left for this angle? 90 as well. So what's the measure of this angle?
90.
What's the measure of this angle? They're all 90 degrees. So if you have a perpendicular line, no matter what angle you look at, that's 90 degrees. So in theory, you could put a box on every one of these. We don't, because it's a waste of time, because we know that all of them are 90 degrees. So what we do is we just put one of them on, and we just need to know that all of them are 90 degrees then. So if I put one of them on, they're all 90. So the symbol for perpendicular, if I want to say something's perpendicular, we use what's called an upside down T. Basically, I'm drawing perpendicular lines without drawing it all the way through. I draw it partially through. So if I wanted to say these two lines are perpendicular, I would say something like this. Now, this is a lowercase l, right? In math, a lot of times we use a cursive L because a lowercase l looks like a number 1. So this is how I'll write my L's. You aren't required to. It's just how I write them. That is L, that's lowercase l, is perpendicular to M. That's it. L is perpendicular to M, then you know to draw it and have a 90 degree angle. Okay, let's put together both the words that we learned. What does perpendicular mean? 90 degrees. I like it. Yeah. If I just say perpendicular, you say 90 degrees. So what does perpendicular mean?
90 degrees.
What does bisector mean?
Cut in half.
Cut in half. So if I'm a perpendicular bisector,
You cut 90 degrees
yes.
in half.
We cut it in half, but we do it and we create a 90 degree angle. So we're not a regular bisector. We're not a regular perpendicular line. We are a perpendicular line that cuts a line in half. Okay? So that's what we're going to get to next, is a perpendicular bisector. That is 90 degrees and it cuts it in half. So it's a bisector that happens to be a 90 degree angle. So if we look over here, do we see a 90 degree angle? Okay. Do we see a line getting cut in half? Yes, because these indicate that this is a midpoint. This is a midpoint of PQ. Is L and M getting cut in half? No. A perpendicular bisector only works in one direction. It does create a 90 degree angle, but it only cuts one line in half. The other line is not being cut in half. So we have to be careful on how we read and write these. So, a line, segment, or ray perpendicular to the segment at its midpoint. Perpendicular at its midpoint. I don't like to memorize those definitions, so I just think 90 degrees cut in half. Man, that's much easier to remember. As long as I know what perpendicular means, and I know what bisector means, perpendicular bisector means cut in half at 90 degree angle. So the diagram to the right is going to show this line cutting the other one in half. This is the line cutting the other one in half. You have a cutter and a cuttee. The line is the cutter. This is the cut E. So we're going to say, okay, that must mean that line ML is the perpendicular bisector to PQ. So we kind of name the perpetrator first, and then the poor little line that got cut in half second. So if you're the bisector, you're named first. If you're the perpendicular bisector, you are named first. So typically the one that's named last is the one that we're going to put our tick marks on. Okay, now we got a big example here. Give it a second and see if you can fill out as many of these as you can, if not all of them. You guys right now are working on A through F. If you have questions, you have people in your pod, or you can do one of these guys where you raise your hand and I can answer that question, and then we'll go through them together. I just want to see where we are right now. I would agree with that too. All we have to do is switch these first two letters. We definitely can't use just one letter because there's way too many of them. Name the sides of angle EBD. Let's go this group. BE, BA, and what was the last one? BD. I'm going to think that's too many sides because an angle only has two sides. Yeah. What was that? ED might be one of them.
Oh, wait, no.
ED. Okay, we already have ED up there. BD. I got BD up there. I got 4 of them, but I only can have 2 of them.
I'll put EB and DB.
EB and say that again?
EB and DB.
EB and ED. Okay.
Or DB. Sorry.
And DB.
EB and DB.
We'll just write all the letters up there. No, it's okay. What do you think it is? I would say it's BE and BD. Because we can only name 2 of them. So let's highlight EBD. We will highlight EBD. So I'll do this. Nope, I didn't. EBD is this one. Now remember, the sides are going to be the rays that comprise it. Your rays are always going to start at the vertex and go out. So I have ray BD and I have ray BE. Those are the only ones that are correct. Those should be the only ones you have on there. So BD with a ray above it and BE are the only correct answers. In fact, if you look at this really quick, you shouldn't have to look at the picture. How I name things, I put the vertex in the middle. That is the start of your ray. Your ray will always go BD and BE. You can actually just look at the naming. Lexi, does that make sense why there's not 3 of them?
Yeah.
Okay.
I think I'm just looking at it like DE and then BA and BD. I don't know why.
Oh, okay, you're looking at the, I see, you're looking at that middle ray. Okay, but it's just the red one. Yep, okay. Classify ABC, back group. What do you think ABC is? You're saying it's straight? I would say it's a straight angle as well, because it goes straight up and down. This pod, can you give me an example of an obtuse angle that's on that picture? EBD, let's go take a peek at that. We have EBD. I would definitely agree that's an obtuse angle. EBD. There were more up there.
ABF.
What was that?
A, B, and F.
ABF would also work. ABF would also work. Did anyone see 2 congruent angles that were on there? Open to anyone. Yeah, what do you get?
EBA and CBF.
Did I get that correct? EBA and CBF? EBA and CBF, they both have that arc on it, so I would agree those are in fact congruent. Because that's what that little arc means, that they are in fact congruent. You might have had a different answer. Do you see this CBD angle? that's 90 degrees. The one above it must also be 90 degrees. So you could have said CBD and ABD. There's also a really cheeky answer out there. What's the measure of ABD or ABC?
180.
180. So you could say ABC is congruent to EBF because they're both straight lines. That's technically correct. Those are two congruent angles. So there's a few answers out there for congruent angles. Name a perpendicular bisector. I'm going to tackle this one for time's sake. We're going to notice that we do have a midpoint of B, because B has those tick marks on the top and bottom. So we have this segment, or this ray BD, cutting this segment AC in half. So the correct answer for that last one should be BD is your perpendicular bisector, because it creates a 90-degree angle and it cuts it in half. All right, once again, we had formatting issues on the next thing. We don't really need this little chunky line here. Do we need to go back? I just see people still writing. We good? Does that make sense? Okay. We don't need this line down here. The angle addition postulate basically says, before we get to the math thing, if I have an angle and I paste another angle on it, doesn't it make a bigger angle? Yeah, that's the angle addition postulate. That if I paste an angle onto another angle, I create a bigger. Yeah, I mean, we just did lunge, but. All right, so we have angle plus an angle. So it says if D is in the interior of ABC. So if I have a big angle and I put a ray between it, basically, I created two angles that we could paste together. So we could then say something like angle ABD, one angle, plus the other angle, so plus angle DBC, is going to equal the big angle ABC. In other words, small angle plus small angle equals a bigger angle. Just like a segment plus a segment equals a longer segment, we can do the same thing for angles. That is our angle addition postulate. You are adding angles. Quick example. If we look down here, we know a bunch of information. We know that PQS is 13x plus 4. We know SQR equals 10x minus 1. Well, according to this postulate, if I take this 13x plus 4 and add it to this 10 minus x, it would equal the total measure. So angle plus angle equals the total measure. So this plus this equals this arc. So then we go back up to the question. It says that, well, PQR is the total arc, is 141. So we have 141 degrees. So angle plus angle equals our total big angle, which in this case is 141. So we're going to have a nifty little equation. We're going to go 13x plus 4, and then we're going to add that 10x minus 1. Plus that 10x minus 1 is going to equal that 141 degrees. I'm going to leave the degrees off because you don't need them when you're adding or subtracting. So we have one angle, which is 13x plus 4, plus the other angle, which is 10x minus 1, all equals 141. Does that setup make sense? Now we just have to solve for x. Solving for x means combining like terms on the left-hand side. So left-hand side has a 13x and a 10x. I'm pretty sure 13x plus 10x would be 23x. We also have a plus 4 and a negative 1. Well, 4 minus 1 is 3. And then it equals 141. Now we're going to go ahead and subtract that 3 to both sides so that we can get rid of that 3 on the left-hand side. So we'll subtract 3. Subtract 3. I'm going to now have 23x equals 138. Here's a good time to have your calculator. I know this goes in there, but I'm going to divide both sides. Remember, the last step should be that dividing by that 23. It is 6. Can I get a second on 6? 6 is good? All right. Now we're going to note I didn't ask for just x equals 6. I said we need to also find PQS and SQR. Well, PQS is that 13x plus 4. So we just need to take that 6 and plug it into that x for that 13x. So if I need to find PQS, I could just go, oh, you know what? The measure of angle PQS equals, instead of 13x plus 4, I'm going to have 13 times 6 plus 4. So I just replace that x with a 6. And here's where it's super nice to have a calculator, because I can just type in 13 times 6 plus 4. What do we get out if we type that in? 82. So that just equals 82. So this is going to be 82. You can put the degree or you can leave the degree off. I'm not picky about the degrees. Some books really are picky about it. Other ones don't even put it on there. So it's up to you if you want the degrees or not. Then to find SQR, we're just going to plug our x in for that one. Measure of angle SQR. SQR is our 10x minus 1. That would be 10 times 6 minus 1, which equals 60 minus 1, which is 59. That almost looks like 69. Let's fix that and make that a 59 degrees. That's our angle addition postulate. It's as hard or as easy if you want to make it. It's just part plus part equals whole. Just like our segment addition is part plus part equals whole. All right, the very last thing we need to do is we need to talk about some terminology. These are the 5 big words that deal with angles. That is vertical, linear pair, supplementary, complementary, and adjacent angles. Let's start with the easy one, adjacent. Adjacent are just 2 angles that are pasted together. Adjacent are just 2 angles that are pasted together. They are 2 angles that are next to each other and share a common side. So an example of an adjacent angle would be just kind of picture 2 angles being pasted together. Adjacent just means pasted together. I think that's the easiest way to kind of think about it. All right, and a lot of times we will number them 1 and 2, so 1 and 2 are adjacent angles. Vertical angles. Vertical angles are 2 angles across from each other on intersecting lines. They are always congruent. So to have vertical angles, you must have 2 lines that intersect, first and foremost. They form an X. Then if you are across from each other, then you are a vertical angle. So for example, 1 and 2 are vertical angles. These are also vertical angles. So every time you have an X, you have kind of 2 pairs of vertical angles, reminding yourself that they are congruent to each other. But notice I put 2 on these and 1 on these. All 4 aren't congruent. You're just congruent to the one across from it. So we would know that angle 1 is congruent to angle 2. Let's skip linear pair for just a second. Let's go down to, I think complementary and supplementary are some of the easier terms that we have. All complementary are 2 angles that add up to 90 degrees. They're just 2 angles that add up to 90 degrees. So an example of complementary angles would be maybe we have 40 degrees and 50 degrees. So complementary angles can be adjacent or they can be away from each other. They just have to add up to 9 degrees. So maybe another example could be, maybe this is 30 degrees and 60 degrees. So they don't have to be next to each other. They just need to add to 90 degrees. Supplementary angles need to add to 180 degrees. Once again, they do not need to be connected to each other. So one example might be this. One example might be, maybe I have a 60-degree angle, and then I have a 180-degree angle. Not 180, 120. Thank you. I saw your face. That didn't make any sense, right? 120. I was just thinking about the sum. I'm very particular. You understanding that they don't need to be next to each other. They could be anywhere. Any two angles that add to 180 degrees are supplementary. And the reason why I'm picky about that is because a linear pair is different. A linear pair must form a line. That's why it's called a linear pair. It is two angles that form a line. So to be a linear pair, you need two angles that basically jut out of this line, kind of like that example I had down here for supplementary. The only difference is these have to be adjacent. That's why they're called a linear pair. They must make a straight line. And it just so happens if two angles make a straight line, they add to 180. So a linear pair is adjacent and supplementary, but in my mind, I just think about it just forms a straight line. And then as long as I know a straight line is 180 degrees, we have supplementary already baked into it. Okay? All right. Let's push through. Are we here now? Whew. Let's real quick look at these. What kind of angles are these? Vertical. What about these two? Are they adjacent? Are they glued to each other? Yep. Are they vertical? No. Complementary? No. Supplementary? No. Linear pair? No. 1 and 2. Are they adjacent? Yes. Are they vertical? No. Are they complementary? Do they add to 90 degrees? Yes, they do, right? They sure do. They're complementary because see how this is 90 degrees? That means the other side is also 90. So it could be two things. They could be adjacent and complementary. Yeah. Are 1 and 2 adjacent? Are they pasted to each other? Yes. They just share a side. So that's adjacent. Are they vertical? No. Do they add to 90? No. Do they add to 180? Yes. Are they a linear pair? Yes, they make a straight line. They do make a straight line. Because when you form them, they look like that. Are 1 and 2 vertical? Yeah. Yeah. Are they adjacent? No, they don't share a side. They don't share a side. Are they complementary?
Yes.
They actually are. Because we're saying these two things are congruent, which means 2 is congruent, which means all 4 of these are congruent. So they are actually complementary as well. Our last one, are they vertical angles? Are 1 and 2 across from each other? Yep. Do they add to 180? They actually do add to 180 because remember when I said if there's one of these, there's actually 4 of them. And 90 plus 90 is 180. So you just have to be a little careful on those particular ones. We're just going to have to skip those. All right, homework. There were a couple I wanted us to skip, I think. We're going to skip number 7. And we're going to skip number 8. So 7 and 8, we're going to skip. That should make this a much more doable kind of thing. And remember, this is due on Tuesday. So you'll have Monday in class to work on it, but give it your best shot.